Hey everyone, and welcome to our interactive science explainer. Today, we're embarking on a very special laboratory mission to uncover the secrets hiding inside the everyday things right in front of us. So get ready to put on your virtual lab coats and safety goggles because we're going to be making predictions, solving challenges, and exploring the amazing world of KSSM Form 1 science together. Let's get into it. Okay, let's dive right in. I want you to think about a glass of milk, the air we're breathing, the salty seawater at the beach, and a heavy, solid bronze bell. Ask yourself, what do all of these completely different things actually have in common? Take a moment, think about it, go ahead and shout out your best guess. Have you locked in your answer? Let's see if you're right. If you guess that they are all mixtures, you are absolutely correct. Even though they look completely smooth and uniform, which scientists call homogeneous mixtures, they're actually hiding a lot inside. A glass of milk? It's a mix of water, sugar, fat, protein, vitamins, and minerals. And that solid bronze bell isn't just one metal. It's a solid mixture of copper and tin. They look totally different, but they share the exact same scientific secret. Here is our science mission map for today. 1. Everyday mixtures. 2. Defining a mixture. 3. Lab separation methods. 4. Interactive challenge. And 5. Real-world science. Section 1. Everyday mixtures. Science all around us. Let's step into our first mission zone and look closely at things we interact with every single day. Things so common we totally forget they're packed with hidden ingredients. Think about the air you just took a breath of. It's not just air, it's this massive, invisible mixture of different gases, water vapor, tiny specks of dust, and even microscopic living things. And seawater? That's a mixture of water, common salt, and various mineral salts. Science is quite literally all around us, just hiding in plain sight. Section 2. Defining a mixture. The scientific truth. Okay, let's put on our scientist hats for a second. The official definition of a mixture is a substance consisting of two or more elements or compounds that are mixed physically, without forming new substances. The absolute key word here is physically, because they're just physically mixed together, kind of like tossing a salad. Their individual properties don't change at all. No new chemical substances are formed. And you know what that means? It means we have the power to unmix them. Section 3. Lab separation methods. Time to experiment. Now, what's really interesting about unmixing things is that the separation method we choose depends entirely on the physical properties of what's inside. Let's look at our first experiment, filtration. This method is absolutely perfect for separating an insoluble solid, meaning a solid that won't dissolve, from a liquid. If we pour a mixture of sand and water into a funnel lined with filter paper, that paper acts like a microscopic net. It catches the solid sand pieces while letting the liquid water drip right through. To be top-tier scientists, we've got to master the vocabulary. The solid that gets trapped up on the filter paper, like our sand, is called the residue. The clear liquid that successfully passes through and drips down is called the filtrate. Just remember, residue stays, filtrate floats. Next up is distillation. Now, what if you have two liquids completely mixed together, like alcohol and water? You can't just filter them, right? Instead, we use their different boiling points. We heat the mixture up. Because alcohol boils at a much lower temperature than water, it turns into a gas first. It travels up, passes through a cool tube where it turns back into a liquid, and drips out as pure alcohol. We call that collected liquid our distillate. Moving right along to magnetic separation. Imagine you've got a pile of gray iron powder completely mixed up with yellow sulfur powder. Think about the physical properties of iron for a second. What do you predict will happen if we hover a bar magnet right over this mixture? Yell out your prediction? Let's see if you're right. If you predicted that the iron would jump right up to the magnet, great job! We use this method when one solid is magnetic and the other is non-magnetic. You just hover the magnet over the mix, and whoosh, the iron powder flies up to stick to it, while the sulfur powder just sits there left behind. It honestly looks like magic, but nope, just physical science. And this brilliantly illustrates our next method, sedimentation. Muddy water is a heterogeneous mixture, meaning you can easily see the different parts. Sometimes the absolute easiest way to separate it is just to be patient. If you leave it perfectly still for a while, gravity simply takes over. The heavy sand settles at the very base, forming a sediment layer, leaving clear water floating right above it. But what happens if you spill oil into water? We all know oil and water do not mix. This brings us to flotation. Because of their physical properties, the oil floats on the surface while the heavier water sinks to the bottom. By opening a little tap at the base of our funnel, we can carefully drain out just the water, perfectly separating the two. So cool, right? Our final lab method today is chromatography, and this one is incredibly colorful. Chromatography separates the components of a mixture based on how well they dissolve in a solvent, like water. We put black ink dots on the bottom of the paper, and as the water travels up, it carries the ink with it. But because different colors dissolve differently, they spread out into a beautiful rainbow of distinct circles as they move up.
Section 4, Interactive Challenge. Test your knowledge.
All right, scientists, it's time to turn this explainer into a game. Here is challenge number 1. In giant food factories, sometimes metal machines get worn down and tiny bits of iron might fall into our food. Yuck. Which method ensures those iron particles are removed before the food gets anywhere near your plate? Think about the physical property of iron. Shout your answer out loud. Excellent. If you shouted separation using magnets or magnetic separation, you nailed it. In factories, our food passes over massive, powerful magnets that pull out any tiny iron particles, keeping everything completely safe to eat. Great job applying your lab knowledge to the real world.
Okay, challenge number 2. Let's say a factory makes a brightly colored candy, but food inspectors are worried they might be using illegal, harmful food coloring hidden inside. Which separation method examines those color mixtures to see exactly what dyes are in there? Think back to our ink dots, yell out the answer.
Chromatography, fantastic work. Yes, scientists will actually take a sample of the candy coloring and use chromatography to separate out all the different dyes. If a harmful color spreads out on the paper, the food inspector catches it immediately. You guys are doing amazing at this. Section 5, Real-World Science, Applications in Industry. Let's zoom out and see how this builds into massive global industries. These separation techniques aren't just for tiny beakers in our science classroom. They are the exact same methods used to keep the modern world running smoothly every single day. Take distillation. Massive refineries use huge distillation towers to separate crude petroleum oil into fractions, which literally gives us the petrol that powers our cars. And sedimentation? That's step 1 in global water treatment. Giant tanks allow dirt and mud to settle, treating the water so it becomes safe before it ever reaches the taps in our homes.
Which brings us to our final thought of the day. I want to leave you with a massive survival challenge. Imagine you're stranded on a desert island. You are super thirsty, but the only water you have is extremely muddy, sandy seawater. Based on everything we learned today, which 2 separation methods would you need to combine, step by step, to turn that muddy mess into perfectly clean, fresh drinking water? Think about it, discuss it with your friends, and keep exploring the amazing science of mixtures. Thanks for joining this explainer, and stay curious.